All right. Today we're going to look at balancing chemical equations. This is something I'm pretty sure you've done in the past. So really today should just be kind of a refresher for what we're looking at here. So looking at an equation that you probably saw a lot in biology, C6H12O6 plus O2 becomes CO2 plus H2O. This is cellular respiration. Really what it tells me is sugar or sucrose, glucose, doesn't matter what the sugar is. This one is a 6 carbon sugar. Reacts with oxygen to produce carbon dioxide and water. Um, if you're looking at this equation, though, there should be some things that are jumping out at you. Namely, I have 6 carbons here. I only have 1 carbon here. I have 12 hydrogens. I only have 2 hydrogens. And oxygens, I'm looking at 8 on this side, 3 on this side, right? So really what we're saying is this equation right here, this isn't balanced. I have atoms that simply disappear, or I have more on one side than the other. And we know from Antoine Lavoisier's law of conservation of mass that this cannot be. Atoms cannot just disappear. Whatever atoms, whatever the number of atoms that I have at the start of the reaction, need to be how many atoms I have at the end of the reaction. So when I start with balancing a reaction, first thing I do is if I'm not working on like a worksheet or a quiz, I'm going to go through and I'm going to add blanks in front of all of the different substances I'm working with, okay? And I'm going to put some numbers in there. It might be a 1, it might be less or more. I'm trying to get that to go away. All right, let's see what that did. No? All right, that's fine. So I would say where you see this kind of arrow, the yield arrow, just the reaction arrow, whatever it is you want to call it, draw a line. Essentially, I'm going to look at my reactants, or the things at the beginning of the reaction, and I'm going to look at the product separately. All right, so over here, I have carbon, I have hydrogen, and I have oxygen. And those 3 things I have over here, even if they are in kind of a different order. So starting off with, I'm just going to figure out how many of each of these things I have. So over here, I have carbons here, so I have 6 carbons. Hydrogens, I only have hydrogens here, I have 12 hydrogens. And then I have 6 plus 2. I'm actually going to write 6 plus 2, 8 oxygens here. All right, so now let's go over to the product side, I should say. Carbons, I only have right here. There's 1 of them. Hydrogens are next to my list, so I got 2 of them. Oxygens, I have 2 here, 1 here, so let's go with 2 plus 1, 3 oxygens. All right, so I would say to start balancing this, 8 and 3, those numbers are going to be hard to kind of get balanced, but like 12 and 2 or 6 and 1. I can start with carbons or hydrogens is, the terminology I would use. I'm going to start with carbons just because it's right away up at the top. It's at the beginning of both of these things. And I can balance my carbons really, really easily. I have 6 carbons on this side, 1 carbon over here. I just have to figure out, so the number I put here is going to be called a coefficient. And just like in algebra, coefficients just are multiplied by whatever comes after them. So if I put whatever number I put here, I'm going to take that times, the 1 for carbons to figure out how many total carbons I have. So now my question would be, so I could ask it one of 2 ways. 1 times what would get me to 6? Or the other way I could word that is 6 divided by 1 gets me what number? Either way, 1 times 6 gets me to 6. Okay, now I put that 6 there. 6 times 1, I now have 6 carbons, but I don't have 2 oxygens here. I have 6 times 2. That would be 12 oxygens, giving me a total of 13 oxygens. Looking at these numbers, 8 and 13, I'm still not liking doing that part next. So I'm going to come back. I'm going to look at my hydrogens. I have 12 hydrogens here, 2 hydrogens here. So I need a number here times 2 that would give me to 12. Or 12 divided by 2 gets me what number? 12 divided by 2 is 6. Pop a 6 right there. I have 6 times 2. That's 12 hydrogens. And then 6 times 1 over here, I now have 6 oxygens. And then 12 plus 6 is 18. All right, not doing too bad. My carbons now are equaled out. They're both 6. My hydrogens are both 12. So now looking at my oxygens here. I have 8 oxygens here, and I have 18 oxygens over on this side now. Well, I've got oxygens in 2 different places over here. I have 6 oxygens here, 2 oxygens here. I know that if I put a number right here, it's going to throw off my carbons and hydrogens, which throw it off over here. Okay, so let's try to not put a number there. Let's just try to make sure that this just stays implied that it's 1. So out of my 18 oxygens, 6 of them are tied up in the sugar molecule, okay? And I don't want to change that number. So 18 minus 6 is 12. So out of this O2 right here, I want to get this O2. I need a blank in here so that something times 2 gets me to 12. Well, just like we did with hydrogens over here, I know 2 times 6 is 12. So put a 6 there. That changes this to 12. 6 plus 12 is 18. So now my oxygens are equal on both sides. That's kind of a tougher one to start off with. So like, let's kind of go down here. Let's say, thank you, Flipboard. Let's say that I have FeCl3 plus a certain number of mg's becoming, I'm just making this one up off the top of my head. I don't know if this reaction actually exists, but I'm sure in a lab we could make it happen. A certain number of iron atoms plus a certain number of MgCl2. All right, so new reaction. Let's go through this one quick. I would say start off, draw a line where I see that arrow. So over on this side, I have iron. Iron's only in the 1 atom, so we got our 1 molecule, so there's 1 there. Chlorines, I'm looking at 3. Magnesiums, right now, I'm at 1. So over here on this side, irons is 1. Next I did chlorines, which we did 2. Oh, I try to keep these things in the same order. Like you could go iron, magnesium, chlorine, and then you're trying to like go diagonal. So I just do that. And magnesiums we said was 1. All right, so starting off looking at this one. Irons 1 and 1. Good there. Chlorines 3 and 2. Magnesium's 1 and 1. All right. So in this case, to start balancing this, I only have the one option. I have to start with the chlorines. I have 3 chlorines in this one compound here, 2 chlorines here. In this case, when I go to balance this, it's rare. You might find some textbooks that allow you to do some fractions and stuff. You do some decimals. Really, though, I would say for 3 and 2, let's just go with the least common multiple, which case is just what 3 times 2 is. So I'm going to try to aim both of my chlorines. I want to try to get both of them to 6. So I know 3 times what gets me to 6? 3 times 2, okay? Put a 2 there. We said that changes my chlorines to 6. Putting a 2 here also changes my irons to 2. I'm going to come back to that here shortly. I'm still working on chlorine over here, though. And I need to get my 2 chlorines to 6, so 2 times what gets me to 6? 2 times 3. That gets me to 6 chlorines, like I said, but I now have 3 times 1, 3 magnesiums. All right, so now let's start off at the top. I have 2 irons here, 1 iron here. Well, 1 times 2 gets me to 2. My chlorines are still at 6 and 6. I have 1 magnesium on this side, 3 magnesiums on this side, so I know 1 times 3 is 3. So now, looking across, all of my things are balanced now. There will be some practice problems up on Classroom. Otherwise, good luck.